So there's no doubt that whoever wins, wins. Instead of having 1 and 2 blades or 3 and 4 blades, that's just stupid.
Okay. So. Alright. So empirical formula is the lowest ratio. Okay? If I have water, H2O, what's the molar mass of that? 18 grams. Say it, are you done? Sorry, quick with the head. Okay, so what if I told you that my mass of my actual compound weighs 36 grams? Okay? So we know that the molar mass of this one is 18. But my real compound weighs 36. So if I had said that my compound weighs 18 grams, my molecular mass is 18 grams, and my empirical, or this mass, is 18, does that mean molecular is the same as empirical?
No.
If 18 grams equals 18 grams, does that mean molecular is equal to no?
Yeah.
Yes, it does. Because my molecular mass is 18, my empirical mass is 18. That means it has to have the same components. What if I say that, all right, let's go back to 36. That means my molecular formula is different than my empirical formula. How do we know how much different? 2 times. How did y'all figure out 2 times? 18 goes into 36. 18 goes into 36. So I take my molecular, divide by my empirical mass, and I get 2. And we call this 2 the coefficient. Basically, I have this number over here, right? N4O8, NO2. What coefficient did I simplify this by? 4. So we're trying to figure out how we simplified it. How much did we simplify it down? We can do dividing what our molecular mass is, divided by our empirical mass. That'll tell us the coefficient that we simplified by. Now, if we simplify by dividing, what's the reverse of dividing? Multiply. So that means that we need to reverse that, or multiply, by this coefficient to get it back up, to get our formula from empirical back up to molecular. Okay? So our formula is H2O. We multiply every part by 2, and we get H4O2, and that's our molecular formula. So you take empirical mass, molecular mass, divide by empirical mass, that gives you a coefficient. The coefficient is how much you have simplified, or the difference between your molecular and your empirical. That means you need to multiply your empirical by that coefficient to get everything back up, or back to where it was for the molecular.
The coefficient in front of the formula?
Because the molecular formula is how many each individual atoms you have. Okay? So that means that one compound has all those atoms, versus you having 2 of a smaller compound. Okay? Make sense? Alright, so we divide our actual mass, molar mass, by our empirical formula mass to get a coefficient. So let's try this. I have a compound with an empirical formula of NO2. It's a colorless liquid that's used in rocket engines. The mass of this colorless liquid is 94 grams per mole, or a molar mass of 94 grams per mole. What's the molecular formula of this substance? So I'm given my empirical formula and my molecular mass. So the first thing you need to do is find out the molar mass of my empirical. You take your molecular mass divided by your empirical to get the coefficient. You increase this every number by the coefficient.
It's a decimal.
If it's a decimal, you need to double it again, just like we did in the last one. What do you mean?
I mean, if your empirical mass, if you divide your molecular mass by your empirical mass and you get a decimal.
You should not, in this case, you should not get a decimal like 2.5 because it is a coefficient that you simplify by, and we can only simplify by whole numbers. We can't take C6H12O6 and simplify it down by something that would give us a decimal. If you get a decimal like 0.99,
Like 2.04.
2.04, that's roundable.
Yes,
That's two.
that's yeah.
That's 2, that's right. I'm talking like 2.66, not really roundable.